Accelerated Algebra 2 stir up here. Just wanted to go over this is chapter 4. This will be during our second regular week. These are notes that you should be watching at home, taking notes on the notes that I have given you. And when you watch the video, there will be some interactions during the video that are worth points. So make sure you are watching them and getting this correct. So we're going to be talking about functions versus relations, domain and range of functions and relations, identifying and utilizing function notation. Let's see, we're also going to describe a graph as even, odd, or neither, one-to-one, or not one-to-one, and identifying functions as even, odd, or neither algebraically. So a relation is just like a bunch of ordered pairs, 2, 6, 10, 9. Okay, it's a relation. It's something that's taking place that's basically getting us both an x and a y component, or two different variable components. The domain are your x values, and the range are your y values. Some of you might have heard domain being referred to as input, and range being put as output. So those are all things. And a function is where the domain does not repeat. Okay, the range can repeat, but the domain can't. If the domain repeats itself, so if you had like 2, 6 and then 2, 10, because the x's repeat, this would not make a function. It still is a relation, but the function itself is where the domain does not repeat. Okay, a relation, the domain can repeat all day long. So think of function and machine. So input, and then you have some sort of output. You put a number in, you get a number out. Okay, we've seen this quite often in the function machine. So are the following functions explain why or why not? Okay, so let's see. This would have given me the point 1, 2, and then 2, 3, and then it gives me 5, 4, 5, 5, and 5, 7. So because this 5 here is repeating, that means the domain repeats. The domain repeats, no function, but it's still a relation. Excuse me. Okay, scroll down a little bit, take a look at what we have down here. Then they want us to do this. And you're like, oh my gosh, how can I have negative 2 pi, negative 3 pi over 2, negative pi, so on and so forth. Notice none of these repeat. So yes, we have a function. Okay. Notice the y values are repeating. We have multiple zeros, we have multiple ones, we have multiple negative ones. Okay. So that's fine if the y values or the domain or the range or the output repeats. Okay, so non-continuous functions and relations. So letter A is not continuous, meaning I just have dots. I would have to pick up my pencil to go from dot to dot. So it's not continuous. You're not including everything in between when you're dealing with a line. Okay? This would indeed be a function, because if we take a look at our x values, we get negative 5, we get negative 1, we get 2, and then we get 4. Those don't repeat getting those points. Notice I just looked at the x values. Okay, I have the x values here, and not necessarily the order I read them off on the board. Oh, take it back. That was letter B. That was letter B. I'm sorry, I looked at the wrong thing. I apologize. But when we take a look at this, I have a 2, I have a 0, I have a negative 1, I have a 0 that happened a second time. So this is not a function. I guess I should do it in yellow. This is not a function. This is a function because none of the x values repeat. And then let's take a look at continuous. Continuous means you could put your pencil down and you could draw these particular shapes. So this does not mean it's a function here, because this x value here and this x value here, x is the same. Okay, there's other x's that are also the same, but you only have to have 2 of them that show that they're the same. So this is not a function. But then this parabola that opens upside down, none of the x values as I go along here, none of the x values repeat. So yes, this is a function. If you had a parabola that opened sideways, which would be x equals something, if you have a parabola open sideways, that would not be a function. So don't always assume that all parabolas are functions. That's a big gotcha. So watch out for that. Okay, a simple way to check if you have a function, especially if you have a graph, is you do something called a vertical line test. So if I draw a vertical line anywhere, that vertical line crosses twice, that would say, no, we don't have a function. But on this one, if I drew vertical lines through each of our points, the vertical line only touches one point. It doesn't touch it multiple times. And the same with our parabola. As we draw a bunch of vertical lines here, it only touches our parabola once. Okay, and that parabola continues to open outwards as it goes down. So, yes, function, yes, function. Okay, pass the vertical line test. That's a simple test. I like that. Let's see, function notation. Function notation is rather than saying y equals something, we actually say the function at f of x. That's f at x. So some people say f at x. Some people say f of x. In my opinion, they mean the exact same thing. Okay? Evaluate functions using functional notation. This should be okay, pretty easy to think about. So what I want to do is I'm going to replace the x on our function here, in this case with 36. So I'm going to go, okay, that's the square root of 36 minus 5. Well, square root of 36 is 6, so 6 minus 5, that gives me 1. Okay? Some people prefer you to write it as 36 comma 1. Some people prefer to say f at 36 is equal to 1. And some people just feel this. Yeah, it really depends upon what class you're taking, but I'm okay with just putting 1 at this point. This one says, hey, I'm going to replace x with 4x. So I'm going to do this. And then you can take the square root of 4 is 2, so I get 2x, 2 square root x minus 5. That's what f of 4x is equal to. That problem's done. And then f at negative 100. I can't take the square root of negative 100 and get something that exists in the real number system. So you're going to say no real solution, NRS. No real refers to the number system, solution. Sometimes that does happen in math. One-to-one and not one-to-one. One-to-one basically means for the domain goes to one range, and basically the range doesn't repeat either. So domain and range don't repeat. Now, what I mean by that is if I had 2 comma 3 and 5 comma 6, that would indeed be one-to-one because my domain is 2 and 5 and my range is 3 and 6. Now, you certainly could have the same number. Let's say we had 2 and 4 and 4 and 6. The 4 on one of them is in the range, that one. The 4 on the other one is in the domain. That is still one-to-one because the domain and range are not repeating. Now, the domain and range, the domain won't repeat on this one. That makes it a function. The range can repeat. So if you had like just numbers like 3, 6 and 3, 10, I'll take it back. Let me go backwards. Let's go 3, 6 and 10, 6. The 3 and the 10 are both the x values. Those are the domain. We're not repeating. But the 6 is. So that would mean it's not one-to-one in that case. So one-to-one refers to both the domain and range don't have any repeating numbers within the domain. They don't have any repeating numbers within the range. Now we want to see if they're even or odd. Even is symmetric. Symmetric. There's 2 M's in there. About the y-axis. So this would be an even function. If that was our x-y axis and it came straight down right through there. If I could fold it over the y-axis and it lies on top of itself, that means it's an even function. An odd function means it's symmetric about the origin. So that could be something like on an xy axis, I have something like this. Meaning, if I held this point right here, the point here would rotate all the way down to this point here. That would be an odd function. So even function would be symmetric about the y-axis. I could fold it over. The odd function, I could actually fold over the x and then fold over the y. That means it's symmetric about the origin. And of course, you can ask about that in class if that's not clear from the notes. Okay, function and context. A car has a 16-gallon gas tank. On a long highway trip, gas is used at a rate of about 2 gallons per hour. We don't know how necessarily how fast the person's driving. The gallons of gas as the time in t and hours goes by after I fill up can be modeled by the function g of t, 16 minus 2t. So the domain, what's the least amount of gas I can have in my car? Well, I'm going to make it a square bracket and call it 0. If I have 0 gallons, guess what? You're sitting on the side of the road going, uh-oh, I'm out of gas. But the 16 is the most gas I can put into this car. That's the most gas I can put into this car. So it's a 16-gallon tank, but it can go from have 0 to 16 gallons in the tank and anywhere in between. You could have 15.56667 gallons. Okay, and then the range you have to think about. Let's take the domain and plug it in to our actual function itself. If I take 0 and plug it in for t, I get 16 minus 0. So 16 minus 0 is 16. And if I plug 16 in for t, you know I made an error. I made an error because, let's see, if I plug 16 in, that's our maximum range, or that's what our tank was. If I plug 16 in, it goes all the way down to negative 32. All right, let's just keep that for right now. We'll come back and work that in a little bit. If I took the 16 and plugged it in here, I get 2 times 16, or negative 2 times 16 is negative 32, 16 minus 32. 16 minus 32 is actually negative 16. Oh my goodness. Negative 16. If I was a math teacher, I'd be really good at this. I'll tell you. I'm just kidding. I'm just giving you a hard time. I make mistakes all the time, my friends. Okay, so the trip took 3.5 hours. How many gallons are left? Okay, well, this is our t value. So we're just going to plug it in. G at 3.5 is equal to 16 minus 2 times 3.5. Well, what's 2 times 3.5? Yeah, it's 7. So it looks like I have 9 hours of driving left based on our tank. And that's kind of a weird way to think about how you would be driving. But, you know, I guess it does work as a function. Okay, we're just going to ignore these. Take a look on Schoology and make sure you know how to do the problems that are assigned. And of course, we'll go over those in class. Make sure you answer the questions in PlayPosit that you're watching these videos on. Have a great day, everybody. Take care of one another.